Define 1 Newton. The formula for force equal to m into a. So if mass is 1 kg and acceleration is 1 meter per second square, then F equal to 1 into 1 and F is 1 Newton. So 1 Newton is defined as a force when acting on 1 kg body produces an acceleration of 1 meter per second square. What is the total momentum of the gun and the bullet before firing? Now before firing, the gun and the bullet are at rest. And if they are at rest, means the velocity is 0. And if velocity is 0, its momentum will be 0, because we know momentum is mass into velocity. And if velocity is 0, we'll have mass into velocity equal to 0. So the momentum is 0. So they are at rest and the total initial momentum is 0. State Newton's second law. According to Newton's second law, the rate of change of momentum is equal to the force acting on it, and the rate of change of momentum is in the same direction of the force. So while giving these laws, you got to state exactly what's in your textbook. This is how the Newton's second law is given in your text. The rate of change of momentum of an object is proportional to the applied unbalanced force. It's very important to write unbalanced force, and takes place in the direction of the force. A body A is heavier than body B, which has more inertia. Now if A is heavier, which means A has more mass, and since mass is a measure of inertia, A will have more inertia. Heavier the body, more is the inertia. So here they say inertia is directly proportional to the mass of the body. More is the mass, more is the inertia. Measure of inertia of the body is mass. A body is moving with uniform acceleration. Is its momentum constant? Now when they said it's uniform acceleration, the very fact the body is undergoing acceleration means there is change in velocity. If there is a change in velocity, there will be change in momentum, because we know momentum, we put it as P, is mass into velocity. The mass of the body remains constant. But if velocity changes, because the body is accelerated, momentum will also change. So uniform acceleration means there is a change in momentum. The minute there is acceleration means there is change in velocity. Change in velocity, therefore momentum will change, because momentum is mass into velocity. Velocity changes, momentum also changes. Why do bicycles begin to slow down when we stop pedaling? This is because of the frictional force. When the bicycle comes in contact with the road, there is a frictional force, and this frictional force acts in the opposite direction. So it's not enough for you just to say frictional force. This is point 1. You got to mention the word frictional force. Second, you got to mention that it is in the opposite direction, and hence it causes a retardation. It slows down and ultimately then it will stop. So 2 points should be there: frictional force and opposite to the direction of motion. Do action and reaction act on the same body? No, they don't act on the same body. They act on different bodies. If you look up at the picture here, the man is pushing the wall. So here is action, acting on the wall. And then to this there's an equal and opposite reaction, but the reaction is now acting on the men. So they do not act on the same body. So they do not cancel each other. So action and reaction, remember, do not act on the same body. They act on different bodies. Here is another example. Here this is action. When the rocket moves, the gases move in one direction. To this there is an equal and opposite reaction in the forward direction. So the reaction here is acting on the rocket, while the action is in the opposite direction. They act on different bodies. They don't cancel each other. What do balanced forces usually do to the body? Remember, these are balanced forces, equal opposite forces acting on the same body. They change the shape of the body, but not the direction of movement. They cannot change the state of motion. They cannot produce acceleration. They only can change the shape of the body. So they change the shape. They cannot change the velocity. They cannot change the direction. If the body is at rest, it cannot be put in motion. And if the body is in motion, it cannot stop. It can only change the shape of the object. Which law of motion gives a measure of force? Now we know the second law gives us F equal to m into a. This is the measure of force. This is given by second law. So the second law gives, Newton's second law gives us a measure of force. The first law defines force. It tells us about force. When a force acting on the body has equal and opposite reaction, then why should the body not move at all? And this is like we explained earlier, is the forces are not balanced. Action, reaction are not balanced forces. And because they are not balanced, why are they not balanced? They act on different bodies. So since they are not balanced forces, they will not cancel each other. Therefore, the body moves under the action of the acting force.